Hey everyone, and welcome. Today we are diving into something huge, literally. We're going to explore the incredible, invisible forces that are always, and I mean always, changing the very ground we stand on. So, let's get right into it.
Think about it for a second. The ground under you right now feels pretty solid, doesn't it? Rock solid. But what if I told you it's actually moving? All the time. It's a wild thought, but it is the absolute reality of our planet.
So, picture the Earth's surface like a giant jigsaw puzzle. Each one of those pieces is a massive slab of rock called a tectonic plate. And today, we're going right to the action, to the edges where these puzzle pieces meet, crash, and slide past each other. This is where all the drama unfolds.
All right, first up, let's look at what happens when plates decide to go their separate ways. We're talking about places where brand new land is literally being born from the center of the Earth.
Geologists have a name for this, a constructive margin. And the name says it all, right? It's constructing something new. The main idea here is super simple. Two plates are moving away from each other. That's it.
Okay, so how does this actually work? Well, imagine the plates are like two giant conveyor belts moving apart. As they separate, the crust gets stretched really thin, kind of like taffy. This makes a gap, and what fills that gap? Hot rock from the mantle rises up. Now here's the cool part. As it gets closer to the surface, there's less pressure on it, so it actually melts and turns into magma. That magma then bursts through to the surface, cools down, bam! You've got brand new crust. And what does all this create? The results are just epic. We're talking about huge new sections of the ocean floor. We get these massive, broad volcanoes called shield volcanoes. And get this, entire mountain ranges hidden under the sea. The most famous one is the Mid-Atlantic Ridge. It's this enormous chain of mountains running right down the middle of the Atlantic Ocean. It was actually the discovery of this ridge that helped prove the whole theory of plate tectonics in the first place. How cool is that?
Okay, so we've seen what happens when plates pull apart, but what about when they move towards each other? Well, that's when things get really, really dramatic. We're talking about planetary scale collisions.
This brings us to what's called a destructive margin. Again, the name gives it away, doesn't it? Something's getting destroyed, or at least seriously rearranged. And depending on what is colliding, you get totally different results.
So let's say you have an ocean plate smashing into a continent plate. It's like a heavyweight versus a lightweight. The ocean plate is denser, heavier, so it always loses. It gets forced down, diving deep underneath the continent. This process is called subduction. And as it dives, it creates these super deep trenches in the ocean. Plus, as that sinking plate melts way down below, it creates a ton of magma that fuels some seriously explosive volcanoes up on the land.
Okay, but what if it's two continents colliding? Two heavyweights, neither one wants to sink. So what happens? There's nowhere for them to go but up. It is literally a slow-motion car crash on a global scale. The rock just crumples and folds, pushing upwards and creating these gigantic fold mountains. You want to see the best example? Just look at the Himalayas. That's what this looks like.
So, to sum it up, these destructive margins are responsible for some of the biggest and baddest features on Earth. You get massive earthquakes from all that friction, you get those explosive composite volcanoes, and you get the tallest mountain ranges on the planet. It's all happening right here at these collision zones.
All right, for our last stop, we're going somewhere a bit different. Here, the plates aren't creating land and they're not destroying it. Instead, they're just sliding past each other. And trust me, it's way more intense than it sounds.
We call this a conservative margin. Why? Because the crust is conserved. It's not being made or destroyed. The plates are just grinding past each other. But don't let that simple description fool you. This is where some of the planet's most powerful energy gets unleashed, all at once.
Here's how it works. Think about rubbing two pieces of sandpaper together. They don't just glide, right? They catch and stick. That's exactly what's happening with these plates. The rough edges get stuck on each other, but the plates are still trying to move. So the pressure just builds and builds and builds for decades, sometimes even centuries. Then, all of a sudden, snap. The plates jerk past each other, and all that stored up energy is released in a massive shockwave. And that, my friends, is an earthquake.
And if you want to know the most famous example of this on the planet, look no further than the San Andreas Fault in California. This is the big one. It's where the Pacific Plate is sliding past the North American Plate. It's a place where you can literally see the landscape being torn apart by this constant grinding motion. So how fast is this happening? About 30 to 50 millimeters a year. You know how fast that is? It's about the same speed your fingernails grow.
I know, it doesn't sound like a lot. But when you're talking about two continent-sized plates grinding against each other, that tiny bit of movement adds up to an unbelievable amount of pressure, just waiting to be released. Okay, let's do a super quick recap. You've got your constructive margins, where plates pull apart and create new stuff. Then you've got destructive margins, where they smash together, building mountains and volcanoes. And finally, conservative margins, where they slide past each other and cause massive earthquakes. Pulling apart, pushing together, and sliding past. Simple as that.
So when you put it all together, you realize something amazing. Our planet isn't some static ball of rock. It's alive. It's constantly moving, breathing, and changing. And these plate edges, they're the architects of it all.
And here's the most important thing to remember. Yeah, we talk a lot about earthquakes and volcanoes, the dangerous stuff. But really, these forces are creators. They're the engine that drives our planet. Without them, there would be no mountains, no deep oceans, none of the continents that we live on. They literally built our world.
And this story is still being written every single day. The map of the world that you see today is just a snapshot in time. It's all going to change, which leaves us with a pretty awesome question to think about. These forces built the world we have now. So what are they going to build next?